think we may be streaming. And if so, hello to everybody. This is one of our first times doing it, so I'm going to just do a little quick check to make sure that everything is going properly here. It does say we are live. Let's turn on. Thing is going. Yeah, I think we are live, and there are actually some people watching. So thank you very much for people watching, and our apologies as we figure out doing this for the first time. So we just finished close to 4 hours of watching the Tesla Investor Day, which didn't have any really big announcements. A lot of people hoped they would use this to announce a new vehicle. They'd use it to maybe some radical new product, something like the robot that went beyond. There was talk of a heat pump, and they sort of giggled a little bit about that one. Maybe it's coming in the future. Instead, there was just a lot of detail about a whole bunch of different divisions inside the company. I've made some notes about interesting elements in the video, which we will seek around, play a little bit of, and talk about the issues behind. What was your impression of the day, Mario? And for those tuning in our previous podcast, I brought Mario back because this is obviously about Tesla, and he's both into self-driving cars and into Tesla, and he's the author of The Last Driver's License Holder is Already Born, and he also writes particularly in the German-speaking market on issues with the future of transportation, as I do at Forbes.com and at Robocars.com. I'm Brad Templeton. So, sorry, go ahead, Mario, on that.
Mm-hmm. Yeah, thanks for joining us today. It was a very long session. We will go through some of these details. My impression was it was really focused a little bit also on where they came from and where they are today and where they're going, and through all the departments of how they do basically cost reductions without making the product worse or trying to make the products worse. And I think there's a lot to learn for competitors of how they approach every single department to, first principle thinking, looking at what is necessary. And I think if I were a competitor, I probably would have to now rush in order to keep up with them.
I think the tiny amount they did reveal about their next generation platform should certainly make some of the competitors sweat. Now, they began the day with what they called Tesla's Master Plan number 3. Now, Tesla has released 2 master plans, and those master plans did talk about the general goal of making the Earth greener, more sustainable energy, environment. But this new Master Plan 3 is all that. They did mention cars. The other ones were heavily on how the cars would do it. So now they're looking at all the elements, and it does bode them getting into other products. This is Elon Musk talking about how he believes that we can move to a completely renewable and sustainable energy industry in all sectors, not just transportation, without really being that hard. It's going to be expensive, but nothing more than we've paid before. So let's look at him.
There is a clear path to a sustainable energy Earth. It's not, it doesn't require destroying natural habitats. It doesn't require us to be austere and stop using electricity and sort of be in the cold or anything. The story, and I think this holds together quite well, and we'll be actually publishing a detailed white paper with all of our assumptions and calculations, is that there is a clear path to a fully sustainable Earth with abundance. In fact, you could support a civilization much bigger than Earth, than much more than the 8 billion humans could actually be supported sustainably on Earth. And I'm just often shocked and surprised by how few people realize this. Most of the smart people I know actually don't see this clear path. They think that there's not a path to a sustainable energy future, or at least there's not one that is sustainable at our current population, or that would have to resort to extreme measures. None of this is true. So we're going to walk through the calculations for how to create a sustainable energy civilization.
And as you watch the rest of this video, you'll find them talking about. I'm probably going to quiet them down, actually, even though I think I've got it automatically producing the video. Mario, unfortunately, you're generating some echo, so you'll need to work on your audio a bit too. So Elon has also lectured occasionally at an organization I helped build called Singularity University, which was founded by Ray Kurzweil and Peter Diamandis. And Elon was channeling Peter in particular there, whose book Abundance talks about those themes. And I talked about them myself in an article from a couple of weeks ago on what I call the law of demand and supply, that says that the more demand for something is, the cheaper it gets because you generate more supply of it. Not actually a law, of course, of nature, but the way to bet is how I describe it. And this is also what Elon Musk is saying, what Tesla is saying. So if you watch the rest of this video, they lay out a plan for how they're going to do all the major sectors, home heating or building heating and cooling through heat pumps, different heat pumps, electrical generation, of course, moving to renewable energy, transportation, which they are, of course, focused on. However, at first he said, actually it was amusing, he said, we can make everything electric except rockets. I'm also into rockets, he reminds people, for those who've forgotten that he does like rockets. And then later he changed his mind on that and says, actually, we're going to be able to make the rocket fuel with electricity. We'll even do it on Mars, to remind people what he's also into. But that's a pretty bold statement. Transportation, even in ships and trains, although that's one of the hardest ones, and also mining materials. And they point out that even though people are saying, oh my God, we're going to have to do a lot of mining for battery materials like lithium, cobalt, nickel, and so on, that in fact the amount of mining we'll be doing, the amount of environmental degradation we'll be doing in resource extraction is going to be way less in this world where everything is powered by electricity and batteries. So they think they need to build about 40 terawatt hours of storage. I'm not sure that will come from batteries. I think there are other storage technologies that will do a lot of that. But some of it will come from batteries. That's where they focus, of course, and a bunch of other big numbers. What else did you see in that? Let me see actually what my next bookmark is. Oh, yeah, here are their numbers. 240 terawatts, of storage they believe needs to be built. 30 terawatts of renewable power generated. That's solar and wind mostly. We have to spend $10 trillion, but he points out that $10 trillion is 10% of 1 year's GDP in the world, and that over the last, I think it was 10 or 20 years, I can't remember what it was, that we've spent $14 trillion just on oil and gas infrastructure. So for less money than we've spent in the last couple of decades on oil and gas, we can have this world of no oil and gas, and so we won't be doing nearly as much resource extraction and land use and mining that goes on to do oil and gas, and that none of this is unsolved problems. This is all just resolve and money to make this happen.
Yeah, I mean, he raises a good point that you always hear about the skeptics on electric vehicles or electricity and this electric storage, that they say that lithium, cobalt, nickel, all these metal and rare earths are rare, which is not true. And when we look at this indices from the decades or even centuries of how prices and the abundance of raw materials and even food has increased actually, and with more people on the planet than like 120 years ago. To remind you, 120 years ago we were about 1.5 billion people. Now we are 8 billion people, and we have today more of those materials available than back at that time. And this abundance comes from the human capacity of being innovative. So we can use much, much less of these materials or none at all. And I think we will be talking about it a little bit later in the drivetrain section, where they reduced those components in the next gen vehicle to zero. And the prices are also much lower than they were in the past. And that is true for all of the 50 or 100 raw materials that, for example, the US World Bank has been tracing over the centuries.
Yeah, so they go into a lot of detail about all the different sectors. I'm not going to do that here during this video, but people can go in, can read, and get the details, although it's all in slides like the one I had there. What's interesting, of course, is that this is not normally something that a corporation would be preaching. And for all the crazy things that Elon has done with Twitter, and boy, has he ever done a lot of crazy things there with Twitter and some of his recent changes, it is worth remembering that when it comes to this mission of making the world a greener place, I'm not sure there is anybody who can claim to have done as much about that as he did. So whatever you may think he's done crazy and wrong or had the wrong politics, and he definitely is doing some of that, still a net positive for the world in my view. So they're going to go on about that. Now, that was the philosophical part of the program. Let me see if so here is the breakdown of the components. So they want to cut the power grid and make it green. That's 35% of the fossil fuels. They want to, so I'm going to have to just skip back just a second. And there we go. Well, so anyway, and transportation and so on. So let's move on to the next bookmark. Well, here we are in what you need. Yes, this is the transportation part. So for EVs, they need to build 115 terawatt hours of vehicle batteries. Okay, so I see what's happened. I haven't used this program before. It has taken away my arrow keys, and I need to use, I think here, some different keys to go back. Well, we'll learn that as we go. But anyway, electric vehicles, those are the numbers for those. Let's move forward to heat pumps. So in fact, they giggled a little bit when they talked about making their own heat pump. They haven't announced one. But in fact, that all the heating we do by burning fossil fuel in buildings is one of the biggest drivers of greenhouse gases. 22% of greenhouse gases coming from heating. And they say, let's move it to heat pumps. Of course, they have a heat pump in the Teslas these days. And heat pumps are both air conditioners and coolers, as well as heaters. They're actually 400% efficient heaters when you're in the right temperature band, because they just move heat from place to place. They do generate heat, but they also just move heat from place to place. And so as we switch to that, there's a potential. Now, I've also advocated, and others are advocating, that we make heat pumps which make ice during the night and during the morning, and that's what we use to cool our buildings during the afternoon and evening, which is the current peak on the electrical grid. So ice is energy storage. If the energy you need is cooling, then ice is a perfect form of energy storage, and you'll never find a cheaper medium for energy storage than water. So you're not going to do too much better than that, although, of course, there is a little bit of inefficiency in taking things down to ice temperature. Then the next area that they talked about was the high-temperature industrial processes, which actually consume a lot of greenhouse gases in order to heat everything up and make the chemicals, make the steel, all those other things. A lot of cool stuff going on. I got a friend who's trying to repurpose what was done for thermal solar, which didn't turn out to be economic as solar power, but use it as a method of generating super high heat for industrial processes from a completely renewable source. So there's interesting potential there. And also, while Elon Musk does not believe in hydrogen for transportation, I think he's right about that. There is a lot of hydrogen used in industrial processes, and you can generate it with this heat and some of these other methods. I don't know if you want to put the sound of them on again. It was distracting me, so we got to learn how to do this. Any comment there, or we'll move on to their next. So this is where they talk about the mineral extraction, and this is what we're doing. Each truck represents a gigaton, and after we move to a sustainable thing, we'll actually reduce the number of mining trucks and materials we extract from the ground, and we'll add in 4 trucks worth of things like lithium, nickel, cobalt, all these other materials. But they're all within the reserves we know about today, and they're definitely within the reserves that we'll find in the future.
Not only that, later they're speaking also about recycling. So basically, once you have the entire recycling cycle running, you reduce, of course, the mining needs for materials for batteries, because you recycle the batteries. Yeah. While if you're mining for oil, you're never basically stopping it, because for every mile that you drive, you have to mine more oil.
It's true. So here they're showing that nickel and lithium are the two ones that we would have the shortest supply of, but still the amount that we need isn't. Here they are, in fact, integrating this
That's the
idea.
chart. Yeah, exactly. That's the chart. The left side is basically what people thinking. They're thinking of a petri dish, where you have some solution in there, and then the bacteria or the viruses are floating around, eating the cell cultures up, and then they are dying. And that's how they think about Earth. Yeah, but actually, the right chart shows that in the end we end up with more and for cheaper.
Exactly.
Because we are a unique species on this planet. We can innovate and learn from that.
Well, so they were preaching to the choir when talking to us. The rest of the world is not as aware of this. So it'll be interesting to see how people, whether they absorb this message or whether they believe it. Of course, there is some chance it doesn't show up true. There's not like a guarantee that new stuff shows up. It's just been the pattern of history, and certainly the way to bet in terms of if you're trying to plan for where we're going to go. So then we got into, I can't remember the names of everyone who spoke.
Lars and Franz.
Yeah.
Lars and Franz.
Okay, there you go. German people might remember their names better. Talking about what they're doing in vehicles. And as I said, they didn't announce any new vehicles. So they did talk about the Cybertruck. They did promise that they would ship it this year. They've been, of course, late on getting the Cybertruck out. They described that basically the Cybertruck's radical design, which has what they call an exoskeleton, that the shell of the vehicle is stainless steel, and it is part of the structural element of the vehicle, and that this turned out to be a lot harder to build than they thought it was going to be, to get it all folding and get it in the right patterns. But they now claim to have solved that, and so they think they'll be coming out with this vehicle. And it, love or hate the look of it, I got to say I'm not fond of the look of it. I don't know what people are going to think about it when it's out there. Some people, they think, like the Prius was really ugly, but people loved that it was really ugly because you could drive around saying, "Look at me, I'm saving the world. What are you doing?" Right? You showed you had a distinctive car, so a lot of people will buy the Cybertruck because it looks different from any other truck that's ever been out there. Hard to say exactly what'll go on.
I mean, the first time I saw it, I was sort of like, "What the heck is that?" Yeah? But I think it is really setting itself off from the rest. Here, actually, Lars and Franz showed also something. Then they had their vehicles up there, and two were covered in a sheet. Yeah. And maybe we see that later, so we should take a look at that once we see it, because I think the one looks like, I don't know, it's not looking like another SUV or so. It's looking more like a
minivan?
Delivery, minivan, delivery van.
Yeah. I mean, everyone's pretty sure. In fact, they actually gave some evidence later, which I'll show you, that they are going to make a low-cost entry-level type vehicle. And that's probably going to be, also sedan, or might be hatchback or something of that sort. But what the other vehicle is, who knows? It might be this is where they've gotten into their changes in their manufacturing process, and I think I have bookmarked some of the videos around that because it was kind of interesting. But the other thing was, they said, hey, well, we're not going to tell you about the new vehicle. But we did get a few little bits. In fact, during the Q&A, one guy threw away his question because he said, please tell me about the new vehicle. And Elon says no. So this video, here we are. I bookmarked this one. This is the nice video they made of how people make cars today. So they paid someone to do some expensive graphics here. I just thought it was a nice visualization. So I put it in the file here. You paint it all together, and then you take it apart after you've painted it. Apparently, I didn't know that. And then you have to put all these things in, and so it's a long and involved process of getting all that stuff together.
In and out of the car.
Yeah.
There's all. We lift the car up. We put stuff from underneath it. We put it down. Then we put the seats in the car, and finally.
That's very labor intensive, as we can see. Yeah. So you can't for some parts you can't use robots. You have to really have humans moving in and out.
That's right. So, and this is based on how they originally made vehicles, but they have now been building new manufacturing processes. And, the things about Tesla that have made them different, this is one of them. We're going to get, I think, the biggest differentiator, which is that they do think like a software company. And they showed some very interesting elements of how they do that, how this assembly process works as well. So let's see if we'll skip ahead to... no, I guess I didn't put that in there, so I'm going to have to learn. It was a little bit afterwards, yeah. I'm going to have to learn how to seek around.
Move a little bit forward.
No, that's the structural pack assembly. I apologize to the
I think
there's
here,
another hint at the next gen
Yeah.
vehicle, just some little picture of how it's going to be put together.
Yeah.
So did we have a visualization? Yeah, here's the
here,
visualization
here
of the
it
new
is,
process. So they're doing a
Yeah.
whole bunch of things in different places. They're not having to put the whole vehicle together in order
Yeah.
to assemble these parts of it the way they do today, which means they can have individual teams working in parallel on getting these things ready and doing QA on them and
Yeah.
doing QA on the components.
Tested some assemblies and
And shorter ways, yeah. You can put more people on the car. I guess they don't have to walk as far. And one of these components that's what we just saw. Yeah, the seats become part of the battery, or the battery pack is part of the underbody. Yeah,
Well, it is.
And so-
It is the structural bottom of the
it's
car.
the structural body, and they install the seats already outside, so just on the thing, and not moving it through the doors in like in the past.
Now, to stop this video from being too long, we're not going to play you all of these videos. This became a 4-hour presentation with half an hour of pre-roll playing, so 3.5 hours. So we're certainly not going to show you any more than a tiny fraction of it. But nonetheless, you can go and look at some of these things if you find they're particularly interesting and you want to see.
Yeah,
But anyway, they believe they can make their
what we see here
factories.
that the cost and the efficiency, so the costs are being reduced dramatically by doing it, by changing this production process, manufacturing process, and the costs and the time, as we will hear also as well. So they are shaving off costs everywhere they can and increasing the output without, and that's what was so important, without making the product worse. So they even make it better.
Yeah, and so they are claiming they can make the factory space needed half the size, at least in the next gen vehicle, as well as I think saving about 20 to 30%, which is part of how they're going to produce this hoped for vehicle that may cost in the 20,000s range. Whether it will cost 25,000 or not is a little hard to say. Okay, so where did we go next? Hang on. Sorry, I hit Alt. There we go. Oh, yeah. So now we get into the electronics and the software that's inside the vehicles. Here they're showing that they have been basically redoing all their own boards themselves. And this is a theme that came up a lot in this section of it and other areas, how they have been moving away from the traditional automotive industry design principle where you have a main automaker who doesn't actually make that much, and you have a tier 1 and tier 2 and tier 3 suppliers who all design and build and program all the individual components, integrate them up and sell them to the manufacturers. And Tesla's trying to move away from that to eventually in this new vehicle be basically making all the chips themselves and making as many of the components as they can themselves, which means designing them, which means the designers are all in the room together. They're working on DFM, design for manufacturing, which makes a big difference, and that not only makes it cheaper, but it gives them a speed of innovation that the other car companies cannot match.
And in addition to that, OTA, over-the-air updates allows it if you don't have to coordinate with the suppliers on updating the software on the ECUs.
Yeah, for
and
sure.
then in a supply chain disruption, as they will be later talking about that, they have in-house capacity to talk about to react to such supply chain disruptions and replace chips with others.
Yeah, so they build their own motors, and here they are showing off the simulator they built. So this is a physics level simulator looking at magnetic field lines as a rotor and a stator move together. And so they said they use this simulator to basically simulate 1,000 motor variations, find the one that would be the most efficient, and they produce better and quieter and cheaper motors, and they're their own motors. They're not motors they get from someone else. So by building these, and yes, they've been building their own processors. The previous slide showed a board that used to have 4 processors on it, and they were able to do an SoC, I guess, to basically put it all into one chip. And they're doing that in many other places. And here's more of the powertrain work that they're doing. We know they make their own batteries. They're making their own packs.
And that helped them. I think I remember the number that they said, for example, we come later to that, the wire harness, sorry, that they shaved off kilograms in order to make it actually lighter, those things.
Yeah. So anyway, they did quite a bit on that, and people can look into that. So, and let's see, control. Oh, I see. I'm unprofessional at this. I've moved my focus away from my YouTube, so they agree. Oh, so one of the things that they're going to do with their motors that they manufacture is they're basically building new permanent magnets, and they're going to make the motors basically no longer need any rare earth materials. Now, rare earth materials are used in most magnets for motors, and the magnets you have on your fridge too these days. However, they're almost all sourced in or through China. And so, in fact, there's one American company here in the Sierras that has a rare earths mine. I actually invested in them. But they still send their materials to China to get them processed, and they're trying to change that. But here, maybe Tesla will screw my investment because they're saying that they're going to build motors that don't need any of these rare earths. I expect there'll still be other needs for them. They're not rare. They're not like diamonds, but they are nonetheless not as common, so it's a little harder to source them. So Tesla said we have that problem sourcing things. The COVID pandemic showed people the supply chain was much more fragile than they thought it should be, and so they now want more control over what goes on.
Thanks, Colin.
So now I've switched over to looking at their electronics infrastructure. I thought that was where the chip part was, but anyway, this is this was the low voltage architecture. So, of course, the car motor is powered by this 400 volt system, the main battery, but most other things in the car are powered by a 12 volt system. And this was their original Model S, which had a more traditional style system with lots and lots of cables running everywhere. And so they went into some detail about how they've simplified it, made it more networked, and also, and I think we'll have a particular bookmark on it before I spoil it, but change, in fact, some of the very fundamental principles of it. So, yes, so they're going to go to 48 volts. This has been talked about in the automotive industry for years and years and years, getting past the 12 volts that we basically had in cars since the 50s and 60s. And now, finally, someone's going to go to 48 volts. So 48 volts, of course, means much less current to deliver the same power. Your wires are thinner and cheaper. We got to fix your lighting so your green screen works better there. But also, 48 volts is basically the highest voltage that's safe. Right, you won't kill yourself from touching a 48 volt line. You might feel a little bit of a bite. Nah, don't play with it too much. I'll try and fix it when you're talking, maybe. But 48 volts is probably the future of a lot of DC stuff, and it's interesting to see. So a big manufacturer is going to do that. Here they're showing the Cybertruck with a even more network. Now, all cars use a network rather than having 1,000 wires to every place. The original network found in cars today is called the CAN bus. It's a pretty primitive network by today's standards. There are a lot of CAN buses in a typical car. They're trying to modify and unify everything into one big network there.
Wires in Cybertruck. And with the next gen platform, we're going to finish the job and eliminate.
Here they mentioned the number that they could reduce from the Model S originally to the Model 3, the wire harness weight by 17 kilograms, about, what is it, 30 pounds, 34 pounds, yeah.
Which is quite a lot if I were a small car. Now, these cars do weigh 4,000 pounds, so it's not as big. You're not going to feel the difference in your acceleration from that. Yeah. But you'll feel it in terms of cost, and you'll feel it in terms of just simplicity of building the vehicle, I think. Yeah. So anyway, they're going to go all low voltage. There's the other vehicle under the drape again. That's all they would show us about what was going on with that. All right. I marked this spot because I was actually a little disappointed that this is something they're just doing now, which is that they have decided that, yes, they have owned over-the-air update because they own and control the software in all their cars. They can write the firmware for every chip in the car, which other car manufacturers cannot do. But the other thing they can do is suck data from the cars, and they use that to design their cars. They use that to design their software, to train autopilot, FSD. Here, what they're doing is they're just having all the cars note how bumpy the road is everywhere, and now the cars are adjusting their suspension when they get to a road that's known to be bumpy. The car will lift its suspension and get a little softer ride in that area, and then get lower when it's not there, which is actually something I thought should happen like 2 decades ago, and I'm amazed that we're people talking about it as a brand new thing. In fact, I want the cars to know the shape of the road completely, and even have the suspension dynamically adapt to the bump that its nose is there, so you can drive on anything and not feel it.
I have heard about reports already back then with the Model S that speed bumps, that it would basically change the suspension when there was a speed bump. Yeah. So that basically was kind of put into the maps. So rough road, that basically like 8 years later, they're talking now about the suspension, how it reacts to rough roads. that, wasn't this already there? I thought it is.
Yeah. So this next video, I liked it because it was one of those ideas that's really obvious, and yet why hasn't everyone been doing it for a long time?
Yeah.
So they said,
cool
hey, we
stuff.
got a big Horkin computer in our car. It's connected up to everything. Why doesn't that computer, aside from being the interface for when people driving it, why doesn't that computer make our assembly process better? So they have a special software system that runs on that computer while they're assembling it. You don't see it when you're running the car. And it's watching the assembly go on. And every new thing that's plugged into it, it's testing it, making sure it's plugged the right way, showing people on the screen, the people who are working on this car. And I'll start it up again. They've sped it up here. But it's showing people all the stages, and it's basically guiding the assembly people to make sure they do the assembly right and they make fewer mistakes in assembly. No part gets plugged in that's in the wrong place, or at least if a diagnostic can be tested. So, I mean, big automakers, of course, they have computers monitoring the assembly line and controlling things. But the idea that having the computer in the car be designed to do that from the ground up, I thought that was pretty sweet.
Yeah. I mean, he is literally what we're always talking about, the electric car, like the Tesla is a iPhone on wheels. It's literally a computer that is already in the assembly process available and tells you what's wrong in the assembly with it or what's missing, and giving you feedback on that. So I thought this is really a cool feature, and so obvious if you see it now. Yeah, so obvious. Yeah, but why hasn't anyone?
Maybe it'll scare the people who don't like the idea of the robots assembling themselves. Here the
Well,
robot
it's the
is,
next step,
is
yeah.
commanding all the humans, all right, now plug 3 into slot B. And yes, you did it right. Good job. So maybe that's a bad science fiction story scene, but it's actually a pretty good way to put the car together. They also have this in the service centers too. So a lot of the servicing of the car is guided by the computer in the car, unless I presume there's a problem with that computer. So let's skip to... this is another one that both surprised me, and then it kind of didn't excite me when I saw the details. But they said that one of their big software efforts is getting ready for the day when they have a robotaxi fleet. All right, so that's they're going to have this. They dream that they're going to make FSD work, and they're going to have this fleet of millions of Tesla robotaxis out there. And so, naturally, they're going to need the same things like the Waymo One app and all the things that companies like Waymo and Cruise and Uber and Lyft have built to manage a big fleet of taxis doing stuff. And I thought, wow, they're already building that? That's a little premature because they don't need it yet. But in fact, what they mostly showed is, again, stuff that I swear 20 years ago I was asking Hertz, why is it when I read a Hertz that the car doesn't know me when I get in it? Right? It doesn't have the seat configured to where I like it to sit and the radio station set to the stations I like. Why don't you do that? Or why don't you get a car company to make a car that can do that? Nobody wants that. Well, Tesla's done that now. All right, so they've got it so that if they give you a loaner car at the Tesla service center, before you get into it, it recognizes your phone as the key. So you just get to walk up to it the way we love to do with these modern cars and get into it, and its seats are set for you, and its maps are set for you, and everything else is as you would like it. And this is something that phones and computers and so on have done for decades. And it's so I was saying, yeah, not that exciting that you finally figured out a car should do that. I was more of a why did it take so long? But at least they are doing it.
Some of the things that we're doing behind the scenes to enable the efficiency, cost reduction, and speed that we are going to.
And let me just.
They also give some numbers. I mean, they're collecting, 30 petabytes of video cache that they have at the moment. Yeah, and they're expecting it to grow to 200 petabyte soon.
Oh, yeah. So they do get a lot of data. Now, the one good thing they've done, and I've just been fiddling around with your green screen for you, so now you look a lot better.
Oh, thank you. Yeah. The light outside is going down, so that's why I changed the light.
Yeah, it is that time of day. But the one thing they are doing that is really good is they're gathering all this data and a commenter says, I wish they would report the potholes to the local council. You think the local council would fix the potholes just because someone reported them? Sadly, I don't think it's the reporting that's the problem. But it actually is true that Mobileye, for example, one of their businesses is they realized, hey, we're doing all this mapping with our Mobileye cameras. We got 50 million Mobileye cars out there. So they now sell data to cities that they learn by driving around the cities. And they tell them, I think they do tell them about potholes, and I think they also tell them about infrastructure and like just where your infrastructure is, because sometimes the city doesn't even know where its infrastructure is, where they have lines and fire hydrants and stuff, and they can get a map of it. So, actually, I think that we might see Tesla do that too. But anyway, what they are learning about is they're learning about how people are driving their cars. They're learning about one of the best things that they did, which I thought, again, something that should have been done a long time ago. They started getting all the data they got, all the telematics data they got from every crash in a Tesla. So they got thousands of crashes. They're noticing where people are hitting. So we're into autopilot, so I'm going to pause. Hang on. No, that's not what I want. I'm going to pause the video because I know we're going to talk about this a bunch. But they're getting data on all the things that are breaking in the crashes, and that's how they're designing the next car for crash tests. And this is one of the ways. I'm sure we've all seen the great crash test results that Tesla has gotten in terms of getting some of the best scores ever. Those of us in the Bay Area all saw this horrific story about a month ago, where a car drove off the cliff at Devil's Slide here, which is this beautiful drive where you're going along the ocean, along these very steep cliffs. And the really dark part of it that came out in the news later was that the father, there's a family with a father, mother, and a couple of kids. The father was trying to kill the whole family, and he drove off the edge of the cliff, and he failed because he was in a Tesla. People just could not figure it out. This car fell like almost 100 meters and
75
onto the
meters,
rocks.
About 240 feet down.
It was
cliff,
nuts.
And it landed upright. And I think there were not even. I think one person had much injuries.
They could
and
almost
the others
walk
were
away.
Relatively, without much injuries, they got away. Wow, yeah.
Yeah. So, and it was a Tesla. Now, some of that we attribute to the better construction they've done it. Some of it, some experts were saying it was just because as an electric car with all that weight on the bottom, it's not nose heavy like your typical gasoline car, which has a big engine up front. Yeah. It's very nose heavy. So every time you see those scenes in movies of people driving those cars off the cliff, the car goes down nose first, smash. Not good. And so this car landed flat, so the crumple zones and the battery pack absorbed a lot of the energy. Yeah. And these people, they pretty much walked away. Not that you could walk away from where they landed, but once they were airlifted out of there, only 2 of them had to go on an ambulance, and the rest, I think, sort of just got into cars. And fortunately, they lived, except for the dad who was trying to kill his whole family.
And the first reaction was when the news was out that the Tesla fell off the cliff. Was immediately the suspicion that it must have been autopilot. It must have been full self-driving beta. Yeah?
This was definitely human pilot.
No,
definitely human pilot.
We could save them. Yeah.
So here they are. They're talking about all the data they've gotten and how they're building their vision system for FSD. Here they have built what I would call a virtual LiDAR. They now call it an occupancy network, basically an attempt to build a 3D model of the world just from camera views, which is something a LiDAR and radars give you for free. So Carmack asks, can you share your cars with people with the Tesla network? Yeah, you can go into Turo or into GetAround. GetAround's my students, by the way. Too bad that their stock's been in the tank. But and you can rent your Tesla there, but Tesla doesn't have anything to do with how that happens. That's true. So, but the one thing they showed here, which I was interested in, they got a question about it in Q&A, which did not confirm my suspicions, in fact, denied them. So if we move a little bit through this, and they're showing just how they can make this. So they're doing something which I've always thought they should do for some time, which is they're having the cars. Here they're still talking about this is their neural network planner. So they now have a planner which they claim does something like this. I don't know what these cars are doing with a pedestrian walking across the street. They're crazy, but the car is quickly slipping in between other cars and not hitting the pedestrian. Always a plus to not hit the pedestrian. This is now a neural network-based planner doing this. Original self-driving planners were not so much machine learning. They've all moved to include more and more machine learning as time goes on. Tesla is big machine learning fans, and so there's no surprise that they've done that. And in particular, they are pointing out that they can now do many things in parallel with their systems, and so they want to. So this is the thing, which they're calling labeling, but what you're seeing here is something that many other teams that do mapping have done, which is you have many cars drive a piece of road, And so different cars drive the piece of road at different times. They see every item on the road from all directions, from all distances. You get a much better picture of the road than you get from just looking out your front camera from a distance, which is all that you've traditionally done with Tesla's non-map approach. And here they are, very obviously building a map. But they were asked about this, and they said, no, we're not building high-definition maps. We don't do that. This is just for us to build more training data, labeling for their training data. So maybe, anyway, I had a great theory that they'd finally seen the light on high-definition maps, and they're insisting they have not seen that light.
Collects data from the fleet, runs computational algorithms in our data center, and then produces the labels to train these networks.
So anyway, but this is auto-labeling, so you can have self-supervised learning, which is definitely a useful thing to do, and they're going to make use of it. And the fact that you see these things from multiple directions helps your make your labeling data a little more accurate. All right, so let's go on to the next.
The road boundaries,
Crosswalks. And they talked again. They've talked about this before, about the immense compute clusters they're building to do the training. Their occupancy rate was trained on 1.5 billion frames.
we have already shipped
Here we get to the
that has bought
once again repeat of what I think is, I'm not trying to libel them, but I call it tantamount to a lie. But they have revealed for the first time this number that people driving Teslas using the FSD beta are having about 3.2 million miles per collision. Now, all the other times Tesla has published data about miles per collision, which they publish every quarter for autopilot and non-autopilot in their fleet, and they compare it to this 500,000 miles per collision number that NHTSA publishes for ordinary human drivers. They've always been giving the Tesla number as per airbag deployment. That's what they're calling a crash, is that we're getting the airbag deployed. The NHTSA number is police-reported accidents. So not every police-reported accident has an airbag go off. I haven't been able to, unfortunately, find out what a good ratio estimate is for that. But one thing I know is that Tesla is being very misleading when they try and say, look at this number for Teslas between airbag deployments and look at this number for other cars between police being called. Because they're two very different things. I mean, yes, the police probably do get called on just about every airbag deployment. I would have to believe they are. But because that's usually pretty serious damage in those accidents, crashes. Not supposed to say accidents. Everyone, anytime you say the word accident, someone will write you and say, don't say accident. They're never accidents. And that's not that they're wrong. It's just they're also pedantic. Not that I'm ever pedantic. I'm never pedantic. But I lecture people about how I'm never pedantic, in fact. However, I don't know. So they're doing the same number again. However, 3.2 million miles per crash. So autopilot, their most recent number for it, which was improved a lot, was 6 point something million miles per crash. So the FSD crash number is twice as bad, but autopilot is almost all, it's about 92% on freeways, and freeway crashes, there's a lot fewer freeway crashes. So it might be a little bit similar to the autopilot number, and this is where Tesla knows the real numbers here, and they don't tell us, and we ask them, please tell us, and of course they don't listen to anyone anymore, but even when they did listen to people, they refused to tell us what the real numbers are. It's just really bad science. Every scientist knows you got to control for all the variables that don't affect your number, and you want to compare apples to apples, and they don't do it. They're deliberately giving us other numbers, and that just makes me say, are they hiding something? Why aren't they willing to tell us? They don't tell us. But I have generally been impressed with FSD and not seeing a lot of reports of crashes with it. And they're saying they're getting one of these airbags. Well, they didn't say airbags in this talk, but I think they're saying an airbag is deployed every 3.2 million miles. It's actually pretty good because FSD is not very good, right? I mean, it's very rarely I get a drive that I don't have to take control over it. And there's other people say, I have drives all the time where I don't have to do it, and I'm sure they do. But I certainly don't. And I live in Silicon Valley, which is where Tesla's engineers live. So if there's any place they're testing it, it's here. But anyway, I think people are actually doing a good job. I think that because it does need intervention, if you were to just ignore it, like some people do with autopilot, and try and put a defeat device on it and read a book, I think you would crash a lot. And so people know that, and so they're actually paying attention to it. With autopilot, I know I got lots of friends who say, nah, I don't even bother looking at the road half the time with autopilot, which is why they're getting those crashes.
I would actually add something to that too. I agree totally. I have the FSD beta as well, and I have to intervene depending on the path, the road that I go, and the difficulty of it, or I disengage because I'm afraid that it's not doing it correctly. But I think we also have to see what they are trying to approach to do. Yeah, they have their ODD, basically the area where they are driving those cars is the entire United States and Canada. And many other autonomous vehicle companies, they are just having, a city which is already large enough, or a certain area only, geofenced. So they add a lot more variables into that, and they try to boil the ocean basically, yeah, not just the pot, but the entire ocean. So, and this of course takes much longer. And of course, then we can discuss a lot about is camera enough, or should they have lidars and so on. This adds also more uncertainty to that probably, yeah. But when you look at the progress that they have and that they made, yeah, it's from a software perspective. I was a software programmer for 15 years. I say this is pretty amazing what they are doing. Yeah, are they done? No, not at all. Yeah, will they have it soon? I'm doubting that. Yeah, but I don't want to shit talk it or trash talk it like a lot of people are doing that. It is just an amazing engineering feat and super difficult. Yeah.
Well, I have trash talked it, but I don't disagree with you there in the sense that I think they've done a lot of good work. I think what happens is there's a lot of people who go out in it and they say, oh my God, look, it's solved. And like Elon Musk, they say it's going to work next month. And he keeps saying that, which is why, unfortunately, you've got to go the other way and tell people, this is an interesting project, but boy, it's still got so far to go. And the way I express it to people is I have trouble getting it to do a trip without needing intervention. It doesn't always need an intervention to stop from crashing. A lot of the interventions I make are because it's either being stupid or slow or it's picked the wrong lane. Just the other day, I was driving from the museum and I needed to turn left and it kept going into a lane you couldn't turn left from, even though there was no going straight at that intersection. So I knew if I let it go there, it was just going to get into a bad situation. I intervened. It probably wouldn't have crashed. But it was definitely a time that it needed intervention. But the thing that people don't understand is that to make a successful self-driving car that you would actually let go out on the road empty the way that Waymo, Cruise, AutoX, Baidu, all these companies are doing, you have to do 10,000 trips in a row without needing an intervention. Not one. People say, look, there's a video of it doing a whole trip with no intervention. Here's 2 trips. I say, great, call me when you've got 10,000. And it's such a different thing, and I don't think people are really understanding that. So let's
unlock driverless operations, which then makes the car
go to the next
way more
bookmark.
than what
Next one was, I think, a Tesla bot then, right?
I didn't actually do much about the bot. But this is a little bit about the bot. And this is Elon touting the bot. He loves it. And so why Tesla will win at doing humanoid robots. There's not that many companies making humanoid robots. Obviously, Boston Dynamics is the one everybody has seen with the Spot robot, which is a dog, and the Atlas, which is a human, and he gets new abilities. And so Elon said, well, we're going to win because, A, we're the best in AI in the world. He's not. That's not right. I mean, they've got a lot of good AI stuff, but there's lots of good people in AI. I don't think that would be the reason Tesla would be an obvious winner. But the other part, which is that they are very good at manufacturing this kind of stuff and learning how to manufacture it. So they are designing their own motors for their robot. So their actuators will be better than people who build from off-the-shelf motors that they're getting. So I think that's a valid point. So that in all the other ways, and I'm not saying that there are slouches at the AI stuff, but they're not the same kind of leader they are as they are in manufacturing and electronics and electromechanical stuff.
Yeah, I mean, they showed some progress. Yeah, in comparison to the first time they introduced the Tesla bot, which was a human in the costume. Now they have hands. Apparently, the things can walk around. They apparently created their own or are working on their own software because he said for humanoid robots the software is not really here. And he's talking also about a ratio, what he thinks of how many robots we will have versus humans. And he thinks the ratio robots versus humans will be greater than 1-to-1. Yeah. And he thinks, of course, that with that also his company, this business will be much larger than the electric car business that he has now. But there are a lot of steps still to do, I guess. Yeah, and then maybe also we have to think of that he shows these robots as working in the factories, doing stuff. That's apparently something very important for him. But it's also a new mobility form. Instead of sending a 2-ton car to pick up your food from Safeway or some store, you have your 60-kilogram robot walking there, bringing you your groceries.
Yeah, I mean, I don't think he's wrong that robotics is going to be huge. Whether it'll be humanoid robots or not, within the robotics field, there's much argument about whether humanoid robots are a wise idea or not. There's a famous, four wheels good, 2 legs bad, to parody Orwell debate that goes on in that field. And there certainly are uses for humanoid robots in doing, tasks that humans do today. I went to the contest that was organized by DARPA for humanoid robots to try and, perform rescue tasks. Because when you want to send people into the nuclear reactors at Fukushima, you do need a humanoid form, and you definitely can't send a person in there. So, if someone could make a humanoid robot that cost only a few grand, you could certainly see there being one for everybody, or more than one for everybody. And so will that be bigger than cars? I don't know if it'll be bigger than cars or not, but it will certainly be big. Whether Tesla will be the leader in it, I don't know. But they have some assets which can give them a hand. So here we're into charging, and I can't remember where I put the specific bookmarks on charging. We had one question from someone in the audience, Eric, who asked, who else has a computer vision data set like Tesla? So Tesla does not get all the data that come from all the cars that drive around. If they could gather all that data, they would have the biggest data set. Although Mobileye, which gets very tiny amounts of data from all the cars, they're in 50 million cars with their cameras, so they get quite a bit of data, although they don't have the wraparound 8-camera view that Tesla has. Companies like Waymo and the self-driving companies have driven many fewer miles, but they have really intense data on each of those miles. LiDAR, many cameras, all kinds of other sensors from many angles. So in terms of sheer volume, Tesla might be the leader, but it's not just a quantity thing here. Anyone with a very large car fleet like Mobileye or BMW or Daimler or Ford or anyone could gather that much data. It's both getting the volume, getting the quality of data, and then doing the right things with it that make the difference. This chart I thought was quite interesting. I've said this before in my writing because I worked it out from some of the numbers I studied, but here's Tesla saying it for real this time, that especially here in New York, right? It's 75% less money for them to put a charger in than for all the other companies. So we just had the federal government allocate $7 billion to help subsidize chargers. And it's all going to go mostly because the way they've written it, it's hard for Tesla to get it. Tesla will figure a way, but nonetheless, right now, Tesla stations don't qualify for it. So Tesla's built for a quarter of the price a much better charging network. You can rant about whether they do FSD well or not, or whether Waymo or Cruise are better, and where Tesla is not the leader. But in this one, Tesla is so totally the leader, it's not funny.
Yeah, pre-assembled as we see here. Yeah, the cables down there, and plug and charge.
Now, here's an interesting chart. This is their cost of running a supercharger other than the electricity. So how much they have to amortize from every kilowatt hour of energy you take out of a supercharger. Their cost is now 12 cents. It's down from 19 cents. So that's actually not too bad. I mean, you don't have to surcharge energy that much. You got to make some profit and stuff. Right now, they're charging about 41 cents a kilowatt hour on average around here. One of the big challenges, I think, is that a lot of people think they're going to use fast chargers everywhere they go, and fast charging is expensive. But Tesla's making it a little bit cheaper. But charging at home is, but she says something later, and I'm surprised. I say this all the time. I rarely see other people say it, but I'm thrilled to see this woman who is running Tesla's charging plans, which is that most people should charge slowly, not fast. And there, in fact, Tesla wants to make it real, something I've wanted for a long time, which is that people charge in the daytime when the sun is out. And if people charge when the sun is out, then you can get renewable power surplus. Because in the morning, there's solar power going cheap because nobody wants it in the morning. They want it in the afternoon when it's hot. So, yeah. And anyway, so yeah, some chatters are answering some of those questions. So,
yeah, I think the big news here was that how many superchargers Tesla has already opened for non-Tesla vehicles. They had numbers like in Europe, apparently 50% of all the superchargers are now open for non-Tesla vehicles. I didn't realize that. And they have now the so-called magic dock, which is basically a plug that allows you to go and charge with your car, and you don't have need to bring your own adapters and can charge with the
sort of. I mean, the problem is that Tesla's cord is too short for most cars. So in order to park at these stations, now they have a new station called the version 4 supercharger. They've deployed a couple in Europe. They haven't deployed them here. It has a cord that's about 2 foot longer. That's good. It's not enough, actually. If you want to charge an Audi e-tron, I don't think you're going to be able to pull it off. A lot of the other cars aren't going to fit, or the only way they can fit is to park and use the wrong station for the place they're parked in, which means that they would. I had to come up with a funny name for it, so I'm calling it dock blocking because they call it the magic dock. So it turns out this problem can be solved if the cars that charge on the right side park on the left, and the cars that charge on the left side park on the right. Then where they meet, you don't waste any charger. And so Tesla could make that happen. They could actually tell you when you drive into the station, because they know when you're driving in, and they know if you pull up the app with a CCS car and say, okay, go to stall number 3 because that one's the right one for you. And if we put the people in the stalls when it's full, then they won't actually have conflict. But the e-trons and see, I don't even know if it's going to reach a Bolt, and Bolt is a super common car. And the Bolt port is on the other side. That's bad. It's on the front. It's by the driver door, I think. Anyway, so here she's showing that magic dock. So it's a nice little design. You while you pull it out, that adapter is locked onto the Tesla cord because it has a lock in it. And so you can't steal it. Not that I think you'd really want to steal it, but you can't. And you can pull that out, and you can put that in your non-Tesla car and charge up. So now, how many? Tesla said they're only going to make 3,500 that way, which is only going to be 10% of their total charges. So it's not going to be that many, but it's definitely going to be better than an Electrify America station.
I read a number. I think if the charging system that Tesla has were a business, it would be like $25 billion.
Okay. So here's the chart I love. They're tracking when is the renewable energy available, and you can see that. And of course, it's wind at night and it's solar during the day, and that's how it's going to be. The sun is not going to start shining at night. And this is when people are charging. The bright blue line is when people are charging. We see there's a mismatch. Tesla wants to fix that mismatch, and I think that's fantastic. It does mean, though, that you do not supercharge at dinner time, which is when I actually do supercharge. Because dinner time power is expensive, and the sun's just gone down. There's no solar to be had, and there's no spare wind either. And it's going to cost you a lot to charge at dinner time on a road trip, unfortunately.
You know whom I often see at superchargers? These are really the Hertz cars. So people, basically the rental car stations, they are charging the cars there.
Yeah, sure. Well, yeah, Hertz has bought a ton of Teslas, and originally they were charging you a lot to rent them, but they've actually improved that. So anyway, that's I think that's really good. I mean, it doesn't surprise me that Tesla knows how charging works. What surprises me is that all the other companies don't. Right? I mean, like it's not like they kept it a secret. I mean, their systems, their plans, their connectors, nothing's been a secret. They showed everyone how to do it, and everybody else still sucked.
And not only that, so it's like it reminds me a bit of maps, navigation systems. Google Maps has been out for 15 years, and everyone else is not able to just make it like them, But the other thing is also that often regulators are coming in and confusing it. For example, in Germany, they had a law that first you had to have a display of how much it costs. So there's a certain regulatory body that you have to know that. So theoretically, technically, according to that, Tesla charging stations were illegal because they were not showing that. Because they were the first ones, they couldn't do anything against that, and now they're coming with that, so they cannot simply shut it down. The second thing was that the regulator came and wanted a credit card slot for them, so that you can. So suddenly you add complications to that thing instead of the regulator saying, well, we know the car, we know the station, we know who you are, you have a credit card behind that, so why not make plug and charge mandatory for everyone? Yeah, and this is what is confused, what is really the huge problem for many people who buy non-Tesla cars, that this stories on charging stations not working, on non-Tesla charging stations not working is just sad to hear.
So unfortunately, the $5 billion in federal money that's been attributed to states to build charging stations requires that each charging station meet a whole bunch of requirements, which Tesla stations do not currently meet. Now, because it's $5 billion, Tesla will do the stupid stuff in order to make it work. Like, you do have to have a credit card reader, right? You can't require that the person have an app. It turns out requiring an app, I mean, it's annoying, but if you just make it a little better, make a unified API or something, a lot of really good stuff can happen if you know that there's some kind of computer interface in charge of making this happen, like assigning you what port to go in so you don't block the dock of someone else.
Just wait, they will have coin slots and bill
coin slots.
If you let the regulators go, because there may be people who have no credit cards, and they also want to have that. So,
my favorite rant phrase is gasoline thinking, and I say this phrase a lot because a lot of people are still stuck in it. It's this idea of thinking like a gas car. You drive around, the thing says E, you look for a gas station, you fill up, and you go on your way, and it only takes 5-6 minutes at the gas station, so that works. And EV thinking is completely the opposite. You don't fill up, you just charge where you're parking already, and you charge while you're doing something you're already going to do. So charging doesn't take any time. Most common activity to do while charging is sleeping. That is how it is for me. It's how it is for everyone who has charging in their house, which is definitely where you want to have it. But anyway, Tesla doesn't have gasoline thinking, but a lot of other people do. They're literally putting charging at gas stations, and many of these grants are going for that. So one of the rules in this program is called NEVI, N-E-V-I, is you got to have 4 stations which will do 150 kilowatts simultaneously. And you can see why you'd want that, right? But actually, it turns out it's much better to have 8 stations that share the power. And you, as a driver, would rather have that rather than have only 4 and find you have to sit and wait while these other cars, by the way, are not taking the full 150 because you only take the full power for your first 10 minutes, and then you start going down. So when you share it, anyway, the point is Tesla knows this. Charging rules should be written by engineers. They should not be written by regulators. I am not going to win that one.
And anyways, I mean, when I'm using that, I'm charging at home as well normally, but when I drive longer distances and the charger is too fast, actually, I'm getting it's getting stressy because
you can't finish
I need to go
you can't finish
to the
your
bathroom, I want to
Big
get
Mac,
a coffee somewhere, and then you already have to run back because you will be punished if you're still plugged in when it is done charging. So
I have proposed to Tesla, and maybe someday they will do it, but instead of trying to get FSD to work, still work on that, but use that technology so that when my car is done charging, the next guy who wants a stall just unplugs it, and then the car leaves the stall and parks somewhere else in the parking lot. What they said that I would have that summon feature like 5 years ago. They still don't have it, but listen, moving in a parking lot is a lot easier than trying to drive through New York, which is what they hope to do. And so they could make it so that there's no waiting at things, and you don't have to worry about how fast it is. I don't know if they'll ever get around to that. All right, let's take a look at the next thing that I noted. And, of course, you've noted a few other things yourself, but we didn't figure. About battery production. Just in general, they continue also to do very well at this. I can't remember what else I noted about battery production, but I'll start it playing, and you can comment on it.
They showed here this process, this new one, that's the dry coating process, I think, the spoonless, however they call it. Yeah. And they use much less footprint. I think what did they say? They really went down like a fifth, a fifth of the original manufacturing size for the cell factory. Is what they are aiming at, and they're already there with the Fremont battery factory, and then the one in Reno, right? So
So again, yeah, the vertical integration, they seem to know how to. I mean, there's a lot of people who argue about it. Is vertical integration all that smart an idea? Shouldn't other entrepreneurial players be able to outcompete you and come up with better battery designs and better motors and so on? For now, that's not happening.
If you need a few space, a few machines, can skip 1 or 2 process steps like drying then the wet coating in the wet coating process. Yeah, I save energy here, I save space here. I have a few machines, few maintenance, and this is where it adds up. And suddenly you pay much less per kilowatt hour than in the past.
Well, I skipped over a couple of sections here, by the way. One on their supply chain stuff, even though they've done a lot of good stuff in that, and their Chinese gigafactory. So you'll have to go in if you want to look at those particular issues. The other thing that's interesting in terms of batteries is that many people seem to think, we're never going to get all these batteries. They think there's not enough lithium, or they think that we're just not going to be able to manufacture it. And they seem to keep proving people wrong on that. And they're putting manufacturing the batteries in huge quantity.
Yeah, Musk even said the US alone has enough lithium for electrifying all cars worldwide.
Yeah, I mean, more than enough. An interesting thing, I've gotten 2 opinions from physicists, cosmologists, on this question. And one told me what I originally thought, which is that all the lithium in my car was actually made in the Big Bang, which I think is kind of cool. You got this because the Big Bang just made hydrogen, helium, and lithium. All the other elements were made in stellar fusion. So lithium is made in stellar fusion, but it actually fuses at a pretty low temperature, but it's all eaten up as soon as it's made. And so, in theory, the lithium in the Earth is from the Big Bang. But there are other cosmologists who have said that no, that's wrong actually, and some of our lithium was made in stars just like all the other friendly elements. So we now move to making the Gigapack. So this is now we're into the grid storage part of Tesla, and they have a lot of parts. I like this little animation that they did about how they're able to make this battery and ship it. It's apparently when they ship it, it is the legally heaviest thing you can ship without closing the road. So they are running up against a wall with that. The thing that surprises me, this definitely didn't match my predictions, is that they make these with the same lithium-ion batteries that they're building to put in the cars. And to me, that's just totally wrong, because there's so many things a car battery needs to be. It needs to be light. It needs to be not catch on fire. Well, they all need not catch on fire, but it has to really not catch on fire because it's in your house. And they need to be low volume, and they need to be able to not degrade too much and last the life of the car. None of those things matter for grid batteries, and yet here we are seeing the car batteries be grid batteries, and it's just because Tesla has gotten so good at making these at scale that people cannot make grid batteries to compete with Teslas. I don't think that'll last forever. I think eventually you'll see people making grid batteries that are only grid batteries. They're no good to be in a car. Oh, another thing, grid battery. You don't care if a grid battery goes to 50%. It's worth half as much as it used to be. Car battery goes to 50%. You say, forget it, this car's dead. I don't want a car with only half the range. Grid battery, no one cares. So there's so many things about car batteries that are special. They shouldn't be the ones in our grid batteries, but for now they are.
And power electronics, it's hard to overstate.
Yeah,
but I don't think that's going to stay. Now we're going to get to a little section on V2G in the end where I agree with Elon on this one. And,
he was talking about basically looking at Australia, where today these things are already in helping to stabilize the grid, and also of course in other locations, often island nations, but because of the certain legal setting in Australia, they have now the option also, to pay customers who are having their own power walls installed to add energy to the grid, and paying them basically for that. And they have an auto bidder, and that's what they were talking about, the software system that allows you to really add or put energy in or take energy out of that and distribute that properly. And there's still, I think, some obstacles in the US, but this is where they want to go.
Yeah, the virtual power plants are really cool, and they're basically, this we're talking about here is that software is basically producing things that couldn't be done with old style of power generation.
And just to say, he said also so you have to understand that in the power plants have to promise a certain amount of energy that they have, and so to cover peaks. And if they cannot, they have to fire up coal-fired or gas plants, and it takes some time until they get on the grid and bring the energy, often 10, 15 minutes. And the batteries like this, they're within fractions of a second, they're online and bring the energy in there. Yeah,
Batteries
so
can do more than
they're
that.
really great stabilizing the grid and much cheaper. And the energy density, he said, is twice as high as a typical gas peaker plant. He called that, like the picture that we've seen, the animation that we've seen.
And that's why we focus so
Indeed.
much on it.
And they can also create any waveform, which is actually very handy if you have weird power factors.
Just as it is about energy.
So, oops, I just obviously clicked on
And then, of course,
wrong-
when I'm thinking as a European, yeah, given the situation in Europe with the Russian invasion into Ukraine, I don't need to rely anymore on having gas in my storage, but I have batteries there, and then I fill them up, with wind power, with solar power, whatever I have at hand. And if I must, maybe generate and charge them with a gas plant, but that's not necessary anymore.
So here we go with the one sneaky detail that I saw. Maybe other people will see it too, because they were trying to not say anything about their new Model 2, whatever you want to call it, their low-cost car. But they put up this chart projecting total cost of ownership over, just over 5 years. I actually didn't even notice that, so I'm going to have to redo my math. And one thing they point out, which is something that not everyone knows, is that because electric cars cost less to operate, as long as you're not fast charging, because they do cost more to operate if you use fast charging, but if you're charging at home, and you're getting sort of a decent grid price, which I don't get here in California where I live, but many people do get a decent price. It's cheaper to drive and cheaper to maintain and costs more to buy. But they're pointing out, look, your Model 3, your base Model 3, is actually lower total cost of ownership than a Corolla today. And so all these people who think, I don't know if they're including the tax credits in this. They might be including the tax credits in this. They don't tell you what all the data are. But one way or another, though, everyone says, oh, my God, I can't buy a Tesla Model 3. It's too expensive. That's only because, and this is a classic problem, which is that people with lower income have a hard time with total cost of ownership math. Dealing with the idea of money over time, and also having to pony up more money if you don't have that in your bank. It's actually hard to do. That's why there are several companies out there that are now trying to provide financing instruments for people to get electric cars, but none of them quite pull this off and give you this number. Because if you walked into a dealership and you said, here's what you're actually going to pay, because you'll pay for your Corolla, and I'm going to ask you to pay for all your gasoline today, discounted in advance, or here's your Tesla Model 3 or other electric car, and the price is lower, then people say, oh, I want the cheaper one. But again, it has to be what they pay today. So you need financial instruments to make that happen. Mm-hmm. But look at the chart. Next gen car is on there. And if you measure the boxes, it's basically 30% less than the Corolla. Actually, it's so the Model 3 is 4.5 points, whatever these units are, and it's 3.2. So it's a little less than 30% better. I think that's right. Well, that's pretty good. That's sort of suggesting that it is going to be in sort of the high 20,000s, maybe even the mid 20,000s. If you can get a $7,500 federal tax credit, you can get a $5,000 California tax credit if you're really poor. Normally it's $2,500, I think, when they have it. Or other states have different tax credits.
I mean, that is for a private passenger car. Yeah, for a semi truck, of course, it's completely clear. For companies, when they are calculating that for their use case, they will see the same kind of total ownership costs per mile over a certain period. But
if you can walk in and buy this, and I don't know if it's going to be a Tesla Model 2, whatever they're going to call it. If you can go in and buy that, and by the time you get your tax credits done, you're under $20,000. Like, how are the other cars going to compete against that? It's going to be difficult.
Well, I think we've seen it already with the price reductions that they had in the last months or so, where they significantly went down with the prices and basically became cheaper than Ford Mustangs and Ioniq 5. With a complete different package and service wrapped around that you don't get with the others. So they're basically really, I have the feeling, taking the air out of the room for everyone. And if they are making it with this next gen vehicle, which is supposed to be revealed sometime soon in a special event, then you almost pity everyone else how they are gonna make it.
Yeah, I mean, they'll get the tax credits too if they make their car in North America and they make their batteries not from China. So several other car companies will be able to get those credits, but they're not going to hit that sticker price. I mean, I got to say, the Chevy Bolt is pretty good, but the Chevy Bolt isn't nearly the car the Model 3 is. Now, this Model 2 may not be nearly the car the Model 3 is either, but I don't know. I think Tesla eventually is going to try and basically differentiate their cars with software differences less than hardware differences, and so that they can, basically give you what you're willing to pay for. And then I think that's going to be a very interesting car market, and it may not be too interesting for some of the companies who are not doing too well with it. So, okay, so yeah, we're going to one of the last points here. Elon and the crew were asked about bidirectional ports. So many people don't know this, but of course, a lot of people love to talk about both V to G, which is when your car can power the grid, and vehicle to home, where your car can power your house when the power is out, and even just vehicle to load, which is just having a plug in the car that you can plug in power tools and things that you want to put in for short use. And Tesla thought about putting that into their cars, actually, and they decided for money not to do it. I'm pissed at them because I would actually like it, the load part. I don't know if I want to power the grid, but I'd like to power the load. But anyway, the Tesla charge connector can't send power back. It's not doable. The Leaf is the only car that actually does it. It's in significant use, and of course, and you need CHAdeMO for that, which is dead. So, but a lot of people have big hopes for it. But anyway, the Tesla's engineers said, actually, yeah, we figured out a way to do that cheaply, so we'll do it in the next couple of years. They didn't make a firm commitment, but that seemed to be what they were saying. But then Elon chimed in and said, I don't think you really want to do it. And he's right. I think it's not as attractive as some people think. Yes, you might be able to sell some of your battery capacity out to the power plant for a lot of money if you can on those really peak days. But as powering your home is concerned, if your car's not there, then your home's going to be dark, he pointed out. So he may be self-serving here because he said you should just buy a Powerwall. Guess who sells you the Powerwall? So maybe that's all he's saying here. But I do believe that grid power should come from grid batteries, which will eventually be different from car batteries, unless you can get car batteries that basically never wear out. If the batteries never wear out, you might as well use them. But if batteries wear out, then using them means using them up. And so why use up your expensive battery when you can get a cheaper battery to use up is going to be, I think, how to go. But anyway, that's Tesla's thinking for now. I don't think you're going to see V to G really pushed heavily by them. I know that some of the other car companies are quite keen on doing it.
I mean, the Ford, what is it, the Lightning also has it.
It has vehicle to, it has the load. I think you can plug your house in with a transfer switch. I don't think it'll feed the grid.
But I think it sounds nice to have, yeah. But would you be willing to pay a few $1,000s more for the case that that you have a power outage? How often do you have a power outage in the US?
Well, the main hope people.
Unless you're living maybe in an area with hurricanes or with things like that, that maybe, or in a where the power grid is not stable, like in Texas.
Well, at the beginning of this program, they went on and said we're going to have to get 40 terawatt hours of storage, not battery, in order to make our green grid. And I don't know if it's that much, but it's a big number. And so a lot of people think, well, geez, if there's going to be all those cars out there, why don't we just use them? And maybe we will. But it's anyway, I'm going to talk about this one. I'm not going to spend too much because I think we're actually at the end. I promised we weren't going to go for hours and hours like we did last time. Guess what? I failed because we had so much to. I've hit the wrong key again. Bad boy.
If we had taken a little bit more time, it would have been longer than the original.
Yeah, and this is a question which I thought we would get into. They did get asked about Mobileye and HW4. They didn't answer really very well. And I think this is going to be a big issue. We'll discuss it later, which is that they have got their new generation of hardware, now called Hardware 4. And they have said they're not going to give it as an upgrade. You're not even going to be able to buy it as an upgrade for your older car, which has their HW3. And I think that Tesla FSD may not work on HW4, of course, but I think it's going to have a lot of trouble working on HW3, the one I own. And that's going to be a problem because that man on the right there promised everyone that your car has all the hardware you need to make this work back in 2016. And so I don't think they're going to be able to deliver on that promise, and they're going to have lawsuits over it.
It's the new cameras that they are having, the new chips probably. They did it when they went from the hardware 2 or 2.5 to 3, that you gave it for free. You could exchange that.
This guy came up to my driveway.
Got that. But I think now they realize it takes much longer. It's much more expensive to put it in. And the cameras, putting new cameras in is probably not so easy than just taking out a processor board and putting in another one. I simplify, of course. Yeah,
the new board definitely doesn't fit in the old cars. It's not saying they couldn't make a board that would fit, but they can't. The other thing they put in, the wiring for 12 cameras. They're going to have 11 cameras. They're going to be able to see areas which the current cameras don't see. I assume they'll have something in these cameras to heat them up, so that if they get fog on them, that they can clear them. But right now, that's a problem. If there's nobody in the car, there's no way to clear off a camera. So I don't know. I think they're going to have a big problem over this. They don't really want to talk about it. Obviously, they have said, "Oh no, don't worry. We're going to make it all work on the old hardware. So you don't need the new hardware." I'm not sure if that's going to be the truth or not. So yes, we did. We have gone once again for longer than we hoped, and I am going to make some shorter ones in the future. If you do hit that subscribe button, I am legally required in any YouTube video to beg you on hands and knees to subscribe. No, you don't really have to. You can do whatever you want. But I tell you, so we did speak for how long did it go? For a little over an hour, and that was only a tiny portion of this thing. So there's actually a lot of more stuff that could be packed in this program. And there'll be more issues to talk about in the future. And, Tesla, whether you love them or hate them, as I've said, they certainly never fail to fascinate.
So I definitely want
in terms of, doing it in interesting ways and showing other people. We didn't talk as much as I thought we would about just how much they've adopted the idea of the software-defined car. And it's one of the reasons that they have been able to have the victories that they've had is that with supply chain, because we didn't talk about supply chain, but a lot of why they succeeded with supply chain is because they do design and make their own parts, and they write the software for them, and they can change how things work. And other companies can't do that, and other companies are slowly learning, but they have not learned yet. So this was our first live broadcast. I think we got a total of 26 different people here at different times. That's actually pretty good for the first one. I'm sure we'll get more people watching it afterwards, and we hope that people find it useful at that point. Other than that, we'll see you again for another hot topic in self-driving and the future of transportation before too long. Actually, next week, we're going to have Michael Sina, who writes a great newsletter on transportation in Scandinavia. It's not going to be all European guests, but that's okay. I have a European passport too, so Europeans are great. And we'll see you all then, and tune in and give your questions. I'm Brad Templeton.
I'm Mario.
And we
haven't
are
stalled out yet on those.